And I didn't videotape first period, so I am going to videotape today. The only reason I have this up here is to show you that that's today. It's dated for today. This is today's thing. And it says warm-up activity first. Get a hard copy, which you've already gotten. That's what you're working on right now. I put it up here because I wanted you to see that there is an activity. This is called a Desmos activity. It's not the calculator. It's an activity. But you're not ready for that yet. So after my lecture, then you have your worksheet, the warm-up. That's what you're going to do that first. You're almost done because you had some time in class. And this is the worksheet that I just gave you that we're getting ready to do work on. That's what that is. This is the activity, Desmos. So hopefully you'll enjoy that activity. That's the only reason I have that up there. But now let's go on and lecture on parallel and perpendicular. Parallel and perpendicular lines. First of all, what does parallel mean? Up and down?
No, side to side.
Side to side?
Two lines that can never cross.
Two lines that never touch, never cross.
Yeah.
Parallel.
Parallel.
So that's very good. Thank you. Okay, so if I'm going to talk about parallel and perpendicular, I've got to give you some basic information. That's the most important information you'll get. Now, Emmanuel, you're going to be confused again, son. Stop doing what you're doing. Pay attention to me and write the notes. You can go back to that in just a minute. And it's real easy to do. Nothing against Emmanuel. I'm guilty of it too. If I'm in a staff meeting and I'm working on something else instead of what they want me paying attention to, the problem is you've tuned everything out. You don't even know what's going on. So we don't want you to do that. I don't want you to be lost. All right. So if I have parallel lines, those parallel lines could look like this, or they could look like this, or they could look like this, or they could look like this. It really doesn't matter. The parallel is parallel. What do you think you can tell me about parallel lines' slope? Yes?
It's like when you have the line right here, but then there's another one, but it's rising up and over. I don't know if that makes sense.
Right. So you've got a rise over run. Okay. So what can you tell me about if they're parallel? What about it?
They don't cross.
They don't cross.
They'll be the same.
They'll be the same. That's important. Parallel lines have the same slope. Now we have some shorthand in mathematics. So for parallel, we're going to do this. Anytime you're talking about parallel, or if I do an assignment and I want you to do parallel something, you're going to see that. Parallel lines have the same slope. Very important information. You'll see here in just a minute why. Parallel lines have the same slope. Perpendicular lines, and I'm going to show you the shorthand for perpendicular, will look like this. Perpendicular lines, and I'm not even going to explain the slope. I'm going to show it. I think it's easier with perpendicular. So if I do a little T-chart, M is slope, perpendicular M would be the perpendicular slope. I like to show it with a T-chart. So if I say the slope is negative 2/3, the way I show a perpendicular slope is I call it flip and change. Flip that fraction. What does that become? 3/2. Change the sign. Positive. So my perpendicular, flip and change. What if I say my slope is 1/2? What's my perpendicular slope? -2 or 1 or -2. That's your perpendicular slope. What if I say my slope is 3/4? What's my perp slope? -4/3. So you guys get my drift, -4/3. Okay, now let me give you a little higher order thinking problem. I want you to think about this before you start jetting out answers, okay? If I want to know the wait, I'm not ready to do that yet. I'll show you in a minute when we do the paper. Okay, so parallel lines have the same slope. Perpendicular lines flip and change.
So if we did like a problem on Excel and it was like asking for the perpendicular and if it was like 1/2 and it flipped it, would it be easier for us to just put 2?
They probably don't want you to put 2/1. They probably just want you to put the 2.
Okay.
I would guess that. Okay, now let's look at the actual worksheet that I have given you. Where is the worksheet? I I must have been on it. Must have been. Wait, I just had that there. Must be up here. Yeah, okay. So here I have, and this is what I was getting you ready for with that worksheet. They want you to write the equation in standard form. We've had plenty of help with this so far, of what we've been doing. They want it in standard form of the line that is parallel. I believe this is parallel. It does right there. That is parallel to this line, but going through this point. Now watch, what you see is what I've already taught. You already know this. We already learned it. All I care about, the only reason they've given me that equation is so I can pluck that slope out. They want the parallel slopes. That means they're going to have the same slope, right? So if the slope of this line is -5, they want me to use m equals -5 because it's the same slope if it's parallel. Now, you guys learned how to find the equation of a line when given a slope and a point, and I will remind you how that was done. You should remember that we had y equals mx plus b. We knew that this was x and this was y. We're just going to plug everything in. So instead of y, I have 15. Instead of m, I have -5. Instead of x, I have -5 plus b. So that means I have 15 equals 25 plus b. So I'm solving for b. Y'all remember this assignment?
Yeah.
This lecture? Take away 25, take away 25, and I get -10 equals b. Are you with me? So now I've got to put them together. I've got my b and I've got my m, so I put them together as y equals -5x minus 10. But it asks for standard form. So you have to go another step.
Plus 5x.
Yep, got to add 5x to both sides. And I get 5x plus y equals -10. And I'm done.
Oh, that's easy.
Why do we have a deer in the headlight look over there?
Um,
She says, I know she's talking to me. What?
you're looking for the y-intercept, right?
You're looking for the b. When I give you the m and the point, you plug it all in. The only thing you don't have is b.
There's this intercept in the equation, so why not just take that?
But we don't want that intercept. We only want the slope in that equation. We're only plucking the slope out of that equation. That's all we care about. They're giving me a slope and a point. I have to find a new b. Otherwise, if I use that slope, think about this. If I use that slope and that y-intercept, it's going to be the same line. They don't want the same line. They want the parallel line. And if I graph both those lines, they would be parallel. Yes.
So these questions are almost exactly the same.
They're very similar. That's why I did this activity. I did this activity so that you could learn how to solve one thing for something and pull that piece of information out and use it to find something else. That's why I did that. Yes,
Oh,
Thank you.
Cameron.
never mind, I actually.
Okay. All right. So that is how you would do a parallel. Let's now go and find a perp. Let's do number 9. Okay, number 9 is going to be perpendicular. So if my slope is -4/3, what is my perpendicular slope?
3/4 positive.
Positive 3/4. Perfect. So now we're going to use this slope and this point to find the equation of a line. Y equals mx plus b. Instead of y, I have a -3. Instead of m, I have a 3/4. Instead of x, I have a 0 plus b. -3 equals b because anything times 0 equals 0. So I've got my b, I've got my m. I can now put it together. Y equals 3/4 x minus 3. But I'm not allowed to have a fraction in standard form, and I have to put it in standard form. Doesn't matter when you clear. I'm going to clear the fraction first, but I could move the x first if I wanted to.
Multiply by 4.
Multiply everything by 4. Beautiful. Multiply everything by 4. Give me a 4y equals 3x minus 12. Now I gotta move the 3 over. And I do it by subtracting it, so I get negative 3x plus 4y equals negative 12. Make sense? It's really not a hard lesson because you've already learned all this stuff. I just had to add some stuff to it. Now, it's going to get to be where it's a little more thinking, and we're going to do one of those, only one. So I want you to pay attention to what I'm going to do. Is everybody good with me right now? Let's look at this problem number 8. Now, they're not going to give me an m this time. They're telling me it's parallel to that, going through this x and this y. Parallel to that? What does that mean? Well, let me go. Is it parallel or perp?
That's perp.
Is it perp? I'm sorry, perpendicular, okay.
There's the same one at the top. Oh, is it for all of them?
Okay, that's okay, I'm gonna do that one. It's perpendicular to x equals negative 8. Perpendicular. Well, let me tell you something else about perpendicular lines, Ethan. If they are truly perpendicular, they form a right angle. Because in the calculator, back when all we had was a calculator to use, I could graph 2 lines that were perpendicular, but they would appear like this. And that's because the calculator screen was not squared. This is not perpendicular. There is no right angle there. Perpendicular is like your x and y axis. If I have these two, they are perpendicular, Emmanuel, because I have a right angle right there. So those are perpendicular. Now, x equals negative 8. Oh, and I have to turn my camera around so everybody in homeland can see what I'm doing. So x equals negative 8. Let me think about what that looks like in order to find the perpendicular one. So x equals negative 8. I go to the x-axis. I find negative 8. Right there's my dot. Is there a slope involved? Just says x equals negative 8. So it only goes through the x-axis. Doesn't go through the y-axis. That doesn't mention y. X equals negative 8. That means my line looks like this. That's what that line looks like. But it wants the equation is perpendicular to that slope. What would my perpendicular slope look like? Very good. It would look like this, wouldn't it? It would look like this. My perpendicular slope would. Because it's got to make that right angle. Well, if this is perpendicular, what axis is this going through? Y. And only y. Does it ever touch the x? No, it never touches the x, so that means my equation is y equals something. Now go back to your problem. Y equals something. So now, I go back here, and here's my, there's my point. It's got to be y equals because this is perpendicular to x equals. So if it's y equals, I go up here and say, well, y equals 7. My equation is y equals 7, and I'm done. That's it.
If we have problems like this in the test all the time,
That's it? I'm past
Yeah,
that.
I'm completely past that.
That's it.
So,
Let me tell you guys something. Now, I have been teaching a long time, and y'all know that. I have taken children that were far worse than you to great heights of making level 4s and 5s. You guys are going to have no problem. None. You will have no. All 3 of my classes this semester are really, should be honors classes. So you don't have to worry about it. Y'all understand what I'm talking about. I can talk, and it's not like everybody don't have to deer in the headlight look for everything I say. You can follow me. Are you expert? No, you're not expert. Not yet. You will be. But you're not yet.
So we don't put the x for
You don't put what?
the x for the break.
On this problem right here?
Yeah.
No, because it's got to be perpendicular to x equals negative 8, which means it's got to be like this, which means y equals something. Period. Just y equals. And y happens to be a 7. Yes.
So would that mean that 11? So for
Number
11,
11.
would that mean x is equal to 6?
So it wants, yes. So it says y equals negative 2. So if I were going to graph y equals negative 2, that graph would look something like this. Well, if it's going to be, is it perpendicular?
yes.
If it's perpendicular, it's got to go like this. So what axis does it go through? x, so x equals 6. Those are the easy ones. Yes.
So would it be so for number 2 on parallel? It's the same problem as number 8.
Okay. So if your parallel to x equals -8 would look something like that, then it means it has to be still going through the x-axis, right? X equals -3. Doesn't that make sense though when you think about it?
So it's literally just a flip, and then for 5 it'll be
Number 5,
So why would you?
y looks like this. Is it parallel? So what should it be? Y equals -4. Are y'all clear?
so for perpendicular it's opposite, and then for parallel it's like
Perpendicular, remember, perpendicular forms 90-degree angle. Parallel is parallel, they never touch. Same slope, flip change.
great teachers must. Yeah.
Y'all understand that? So that's all I needed to explain. You just need a little bit of other information. So all you have to do at this point for the rest of the period, you know what you got. You got your warm up if you're not done with that. This thing that you're working on right now, what I want you to do is I've got the key up here. I'm not grading this. This is for you to learn because I'm going to grade that other thing you saw at Desmos.
Yeah.
Learn and then do your Desmos that I'm grading. So you can come check it with the key up here.
Okay.
Okay? There you go. Bye.